And number one, I think I'd like to go over the equinoxes and solstices first. And so allow me to, I got so many things to find here. I can find the right stuff. All right, I made a movie for you real quick here, kind of a goofy looking movie. Can you all see it? Okay, so I'm going to start playing this movie. It's really a GIF, but okay, hopefully you guys will see it. Here it says autumnal equinox. We have 2 equinoxes and 2 solstices. And this happens because the Earth is tilted as it goes around the sun. It's tilted 23.5 degrees as compared to the Earth's orbital plane. Remember, orbital plane of the Earth is like this gigantic sheet of paper that the Earth travels on as it goes around the sun. So as compared to that, instead of being 90 degrees going around the sun straight up, it goes around the sun tilted. If it was not tilted, then the sun will always be on the celestial equator. But because it's tilted, the sun goes above the celestial equator, then it goes below the celestial equator, maximum 23.5 degrees, the same as the tilt of the Earth. So let's see the video, then I'll show you guys more and more and more until everybody gets this equinoxes and solstices. So let's take a look at this video. Okay, so here, I want you to remember something. Remember what the celestial equator is, right? Celestial equator is a projection of this. This is the Earth's equator. And celestial equator is on the sky. So there's this much, much bigger equator in the sky. It's called the celestial equator, right? I'm kind of tracing it right now like this. Now, in this position here, from the Earth, when you look at the sun, for us in the northern hemisphere anyways, the sun appears to be below the celestial equator. Look at this. Just below. Below, right? Now, as time goes on and we go around the sun, here, the tilt of the Earth makes no difference whatsoever. Because we're not pointed at the sun, the axis is not pointed away or towards the sun. So therefore, on this day, which is March 20th or 21st, depending on the year, the sun appears to be on the celestial equator that day. And so when the sun is on the celestial equator, we call it an equinox. Now, this happens twice a year. Once when the sun is on the celestial equator, the first day of spring, and we call that vernal equinox. So vernal equinox, vernal means green. Equinox means equal nights, which means the sun is going to rise exactly due east, and you have 12 hours a night, 12 hours a day. That's what they call it, equinox. That means equal nights. Vernal means green, so that's green equal nights, right? That's the first day of spring. The sun rises exactly due east, and you have 12 hours a day, 12 hours a night in San Diego. Okay, let's see what happens next. All right, now here, this is actually, it's kind of out of order here, but in the summertime for us, after springtime, right after vernal equinox, as you can see, here is the celestial equator now. This is the equator of the Earth. Projected onto the sky, it becomes the celestial equator. Now, the sun is above the celestial equator, but 23.5 degrees max on the first day of summer. So when the sun rises, it rises 23.5 degrees above the celestial equator, north of the celestial equator. So when we're pointing at the sun, when the axis of the Earth is pointing at the sun, then the sun is going to be in what we call the summer solstice. For us in the northern hemisphere, that's the first day of summer. For people in the south, that's the first day of winter. It's the opposite. Somebody's got their voice on. Can you please? Yeah, thank you. Okay, so here is above the celestial equator. So it rises north of the celestial equator. This is called summer solstice, the first day of summer. So like that's June the 21st, sometimes 22nd, depends on the year. Because sometimes, you know, the years change. We have 366 days, we have 365 days, we have 365 days and a quarter. So if you want to see the exact sun or the exact position of the solstices or equinoxes, you're always going to be 6 hours off. So you add 6 hours to what you saw this year. Next year is going to be 6 hours ahead. Year after, 6 hours more. Then it goes past midnight, becomes an extra day like that. It's okay. You don't have to know exactly that. But just in case if you wanted to know. Now, what happens again? Here, all right, so here, this is the beginning of fall. In this case, again, both sides of the Earth are experiencing the same amount of light, and we're not pointing towards the sun or we're not pointing away from the sun. And so the sun is going to be on the celestial equator again. This is another equinox, equal nights, except this happens beginning in autumn, September 21st or 22nd. And so we say this is autumnal equinox or the fall equinox in the north anyways. So this is the beginning of fall for us in the north. Any questions before I show you more? I'll stop this before I get away from this. Well, we're 1 minute away from landing, huh? Sheesh. All right, you let us know when we actually safely land, Jenny. God, I hope you land. All right, no questions. I'm going to stop this now. I'm going to give you something else here. I'm going to show you now this. All right, what I just told you, I'm going to show you now on the sky. So what I'm showing you now is in San Diego, 32.5 degrees north. We're looking south. You never find the sky north. It's going to be north of the celestial equator. This red line is the celestial equator. It's going to be north of the celestial equator, 23.5 degrees on the first day of summer. And then it crisscrosses the celestial equator as seen from the Earth. Then that's going to be going below the celestial equator. Then it's going to go way, way, way down. And then that's 23.5 degrees below the celestial equator. That's going to be the first day of winter, December the 20th. And then it's going to come up again. And that's where we're going to have the vernal equinox. So let's take a look at it for a second. So I'm going to run this. Every click in the computer is going to be one whole day. So let's take a look to see the path of the sun during the year from San Diego. All right, now it's going to be winter solstice, vernal equinox, summer solstice, autumnal equinox, solstice, equinox, solstice, equinox, like that. So this is the first day of fall, right? All right, here it says 9:21 is right on the celestial equator, which means it's going to rise on the celestial equator too. I guess I could change the time so you can see it rises exactly due east at 1 o'clock here. I'm going to change the 1 o'clock to like 6 a.m. This is p.m. So let me change it to 6 a.m. 6 a.m. Great. 6 a.m. I can't change that, can I now? Let's make it to 7 a.m. then.
They landed, Professor.
They actually landed, or did
Yeah.
they? Yay. Awesome. Awesome. Thank you so much. Whoa. They're eating more peanuts. They opened up a champagne. Yeah, we just landed on Mars, you guys. We're going to figure out if there's any life. Has ever been any life on Mars, or there's any present life on Mars. And it's going to be exciting, you guys. It's going to be very exciting. Let's see what happens in our lifetime. If it didn't happen, then I wouldn't be able to see it. Because the next time we can send something out is going to be like 10 years from now. I'm going to be 77 or something. I'll be dead by then. So, yeah. So anyways, take a look. This is exactly due east on the celestial equator. All right. So this is the first day of fall. Exactly. So on equinox, the sun rises exactly due east. All right, I'm going to change the time again to 1 p.m. now. 1 p.m. There we go. All right. So now what happens if I keep going here is the winter solstice. This is as far south as the sun is going to get. So here's the celestial equator. It's 23.5 degrees below the celestial equator, south of the celestial equator. And of course, in the background, you see all of these constellations that we call zodiacal constellations. And, you know, in astrology, we don't have constellations like this. We have houses. So every, let's see, every 30 degrees of the sky was 12 times 30. Yeah, 30 degrees. So this whole thing is a house. This whole part of the sky is the house of Sagittarius, a house of Scorpio, house of Libra, right? Whereas in astronomy, we have, let me show you. We have outlines here. We have boundaries. So like you see these boundaries here, they decided that this is the boundary in 1920s. They decided that this is the boundary, and because it was the International Astronomical Union, now all the maps have to have these, you know, boundaries. So if the sun is within this boundary, the sun is in the constellation of Sagittarius. The sun was here, that'd be in the constellation of Scorpio. The sun is here, though. It won't be in the Scorpio, it'd be in Ophiuchus. So some people say that's the 13th sign of zodiac. What they don't realize is, yes, it's true that the sun goes through the constellation of Ophiuchus, this snake handler. It's true. But it's not the house of Scorpio. The house of Scorpio is all of this. This is called the house of Scorpio. So if anybody says that, you go, well, you know, it's a house. It has nothing to do with the boundaries of a constellation. All right. Okay, now, this green line that you see here, this is called the ecliptic. The ecliptic, you can put this down if you like. The ecliptic is the yearly path. Ecliptic is the yearly path of the sun on the celestial equator. So if you watch this, now you can see the sun is always hanging on that green line as we see it during the year. So this is,
how do you spell ecliptic?
Ecliptic, E-C-L-I, Ptic, P-T-I-C, ecliptic. I wonder if it tells me.
And Professor, can you explain that again?
Sure. It's the yearly path of the sun on the celestial sphere. So this is a celestial sphere we're looking at, right? This green line represents the ecliptic. So as the sun is observed from the earth, it's always on this green line during the year. So if you watch it, you can see every day it's on that green line. All the time it's on that green line. That's the yearly path. So that's the ecliptic. And the ecliptic runs right through the zodiacal constellations. Those are all the constellations that appear to be in the background of the sun. So if you're born here, we say you're an Aquarian. It says 215, 216 or whatever. If you were born here, your mom gave you birth in the hospital, you go, oh, you're an Aries. It's called a sun sign. And here it will be constellation, it will be Virgo. So you'd be a Virgo. So that's why, you know, we have all these houses. The ancients must have known, right? Because otherwise, how could they see Virgo? It's in daytime, right? So in daytime, you don't see anything. Let me turn on the actual real sky. It's all blue. You can't see anything. So they must have known.
Professor, does the ecliptic ever move, or does it just stay there on that line?
On the celestial sphere? No, it moves. Everything moves, including the celestial equator, including the equinoxes, including the solstices. Everything moves. So now during solstices, solstice means sol, the sun, S-O-L is the sun. Solstice means sunstop, because during those sun stops, the sun appears to be motionless, like it doesn't really move that much during the day, right? And so that's why they call solstice sunstop. And then equinox means equal nights. Vernal means green. Vernal equinox is a pretty important place in the sky, even for astronomers now. That's how we measure the coordinates of the sky, starting with the vernal equinox. It's kind of like the Greenwich of the sky. You know, Greenwich is on Earth. This is in the sky. So it does the same thing as Greenwich in the sky. Okay. Any questions about this?
I have that we have 2 equinox, autumnal and spring.
Correct.
And then the vernal is what?
Spring.
Oh, got it. Thank you. Sorry.
There's vernal. No worries. Well, don't be apologetic.
Green.
There's the vernal green equinox. So that's the spring equinox. So on that day, here we go. It says 3/21, March the 21st. But it could have also been here, March the 20th. So it depends. Every year goes forward 6 hours because the year is 365 days, the way we count it. But it really takes 365 days and a quarter, 365 days and 6 hours. That's why the position of the sun in our time on Earth goes forward 6 hours every year until it reaches midnight. And then we go to the next day. So it'll be on the 21st, like that. All right.
So I'm sorry, you say the equinox is always 6 hours later each year.
Correct, correct.
And the path of the sun takes 365 days to go, but it takes 365 days plus 3 hours to
Plus
make
6 hours.
Huh?
Plus 6 hours. 365 days and 6 hours.
And that's the ecliptic. The ecliptic takes 365 days?
No, the Earth takes 365 days to go around the sun.
Thank you.
You're welcome. 365 days and a quarter. So why do we see what we see? It's our vantage point from the Earth. What you're looking at is the way we see the sun during the year. So sometimes the sun is above the celestial equator, sometimes the sun is below the celestial equator, and so on. So to find out where the sun is, you have to know where the celestial equator is. So in San Diego, this is south, right? And if I measure this angle, let's measure it. What does it think it's going to be? How much of the southern sky is visible from San Diego?
32.5 degrees north.
No, the other way. 90 minus 32 and a half. 57 and a half.
57 and a half.
Right. So this is 57 and a half degrees. So now we say.
We say north along with that. I'm sorry, Professor.
I'm sorry?
When you say it's 57.5 degrees, do we need to say north or south?
No. We see 57 and a half degrees of southern sky from San Diego. So this is San Diego. This is the celestial equator. Everything to the north of the celestial equator is in the northern sky. So Pisces in the northern sky, Aries is in the northern sky, Aquarius and Capricorn are in the southern sky. So now the sun crosses the celestial equator, goes into the northern sky for half the year, then crosses the celestial equator, goes to the southern sky. That's why I keep showing you this, so you can see how it perceives the sun as it moves, as the Earth moves around the sun. Now, one way you can do this is the following. Let me just stop this for a second. Let's see if I can explain to you with just your head. So now pretend that your head is the Earth. Can you guys pretend that? Just pretend. So your head is the Earth. Now, where's the equator of the Earth? Your nose is the equator of the Earth, right? So here's the equator of the Earth, all right? Now, pretend that the sun is the monitor in front of you, the screen in front of you, right? Here's the equator of the Earth. Remember now, the equator of the Earth, this projection is the celestial equator, like that, right? So this is celestial. Now, look. When the Earth is tilted towards the sun, the monitor is above the celestial equator. See, I see the monitor up here. Then 6 months later, we're looking at the sun like this. So now the sun is below the celestial equator, you see? And so now when we're at the vernal equinox, we're like this. If the Earth didn't have a tilt, the sun will always be on the celestial equator. It wouldn't go north and south of it. It's just because of the tilt of the Earth that we see the sun north and south of the celestial equator. That's the most difficult thing I'll try to convey to you guys this whole semester. Hopefully I can do it with a smile. Sheesh. All right. Right on, man. Let's get going, huh? All right. Sheesh. So Okay, so we talked about zodiacal constellations being in the background of the sun during the year, 12 of them. We don't have to memorize them. We talked about equinoxes, we talked about solstices, and we talked about ecliptic. And what is the sunrise? The first day of springtime?
Spring.
Vernal equinox? Where does the
Directly
sun
due
rise?
east.
Exactly due east. Exactly due east. So twice a year it rises exactly due east. Sophie, sorry. It's okay. Sheesh, she was driving. All right. Okie dokie. If there's no questions, I'm going to get into the precession of the Earth. Now, this is kind of weird. Now, I don't know if I can spin a coin for you guys. You guys have seen a coin spin, right? The coin spins, you go like this, you go bang like this, and the coin spins, and then it dies out. Why does a coin die out? Why doesn't it just
Gravity.
fall out?
It
Watch
runs out of the forward motion.
Okay, listen, you guys have played with a top before, right? Big top.
Yeah.
You spin the top, it keeps moving. What does the
That's out
top
of
look like?
centrifugal force energy.
Okay, let me show you the top here, you guys. I'll just make a top. I can't really do it if I have to raise my table. You guys see the top, right?
Yeah.
So this top spins like that, spins, but it doesn't just die out like that, right? What does it do? It goes like this. It goes, right? Why does it go like that? Well, it's because the gravity of the sun and the moon are trying to bring the Earth down. So as the Earth spins and is tilted like this, the moon says, Earth, come on down. Like, shh. Sun says, Earth, come on down. The Earth says, I don't want to come down. I don't want to come down. So instead, it starts spinning like this, just like your top does, right? Your top spins and spins, then it goes, It's because the Earth's gravity is trying to bring the top's edge down like this. The top goes, I don't want to come down. So then it does this. Conservation of angular momentum, they call it in physics, right? But for now, we just say it's the gravity of the sun and the moon are trying to bring the Earth down. And the Earth says, I don't want to come down. So what happens instead is the Earth does the same exact thing as a top. Earth is a top. Now, this top that we spin on the Earth, it dies out like in a minute. Although I've seen some tops that are selling for $100. Have you guys seen those tops advertised? They spin for hours. They're magnetic or something pretty impressive. Regardless, so the Earth starts spinning, the axis of the Earth starts spinning like this. We say the Earth's axis draws or scribes. The correct word is ascribes, S-C-R-I-B-E-S, scribes a circle onto the celestial sphere. So the Earth's axis scribes a circle onto the celestial sphere. That's pretty wild. Yeah, it is pretty wild.
Will you please say that one more time?
Sure. Remember we said the Earth is a top and it's spinning and the moon and the sun want to bring it down as it spins like this? Well, it refuses to come down. So instead, it starts spinning in this other axis like this. So it does this. So this is a pole of the Earth, axis of the Earth, north axis of the Earth. Instead, it draws a circle onto the sky. And I'm going to show you that in just a second. I'm going to explain it first.
Professor, just to clarify, Earth's axis scribes
a circle onto the celestial sphere. Yeah.
Thank you.
But it takes 26,400 years to do it one time, right?
26,400.
Correct. Now, where's the point where the axis of the north axis of the Earth is pointing to in the sky? What is that called?
North Celestial Pole.
Excellent. Who said that?
Lourdes.
Lisbeth. Oh, thank you, Lisbeth.
No, Lourdes.
Was it?
Lourdes.
Give me your last name, please.
Guerrero.
Spell it for me, please.
Guerrero. ERRERO.
Wow. Okay. Got you. You get a point for that. Thank you. That was quick. Excellent. That's right. This is called North Celestial Pole. So now, because of this, something we call the precession of the axis of the Earth. You can call, if you spin a top, you say the axis of the top is precessing too. That's the precession of the axis of the top. Same thing, you know, when the top does this. So the position of North Celestial Pole is continuously changing. Like as we speak right now, its position is changing just a little bit. You can't really see it except with a really good telescope, you can see it. So let's show you that. Let's show you the precession of the Earth's axis.
I have a question regarding this.
Yes, please.
Eventually, will the Earth's axis become perpendicular to the sun? Because like how a top falls while it's spinning, will the Earth kind of eventually
You mean
fall
point directly
all the
to
way?
the sun? I don't think so. It changes a little bit all the time. Even that 23.5 degrees is changing. But I don't think it'll ever be like that.
I've heard some people say that because of the top spinning, eventually when it does, like what he was just saying, like it stops, it causes a polar shift. Have you heard of that before?
Yes, but not all the way into its orbital plane.
That's more of a magnetic shift, is it not?
Well, the magnetic shift is happening right now. Like if you wake up tomorrow morning, North Pole and the South Pole may change polarity. So North magnetic port may become South magnetic port tomorrow morning when you wake up. It's going to happen one of these nights. I don't know when. I think in your lifetime.
That's every how many years does that happen?
Well, that depends. That depends. We
It
haven't
just
seen
might
that happen.
happen out of nowhere. Just they don't have an explanation as to why.
Yeah, it would happen. But that has to do with the core of the Earth. That's the polarity of the Earth, has to do with the motion of the core of the Earth, which is metal. Every time a metal moves, like in a liquid like that, it makes an electric field. Electric field that is moving makes a magnetic field. So anyways, can I get back to this guy, you guys? So let me go back to the year. What's the year right now? I'm going to go year one. Okay. I'm going to go year one, day one. What happened on that day at 8 p.m., you guys? 111. Is there a year 0? No. There's year 1. Year 1 is when Jesus is born. Look, 8 o'clock. I'm just guessing he was born at 8 o'clock. 111 AD. Jesus was just born. So this is the sky when Jesus was just born. And when he was born, North Celestial Pole was over here, nowhere near Polaris, the North Star. So when did it become like this then? Let's take a look. This is the days and year and everything. So you can see the year here. It's increasing by 10 years per click of the computer. Let's stop it now. This is the 1400. Still not very close to the Polaris. Aha, pretty close. This is 19th century. So only from like 16th, 17th century have we had Polaris very close to North Celestial Pole. This is, let's see, this is pretty close to today. It's 2028. Pretty close, right? Well, what's going to happen in our lifetime? Not much. But look what happens over thousands of years. It's scribing a circle onto the sky. Remember we said? So look at this. Now, array in the year 4000 is going to be very close to North Celestial Pole. So array is going to be a new North Star. And then another 4,000 years is going to go by. And Aldramin is going to be North Star again. There is a North Star is going to be Aldramin in the year 8000. So North Stars are going to change. Now I'm going to speed this up so that I can show you a little faster.
And is this what precession?
This is what precession is doing. This is the axis of the Earth, is scribing, drawing a circle onto the celestial sphere. So we're looking at the celestial sphere, and we're looking at where the Earth's axis is pointing to. So this is North Celestial Pole, where the axis of the Earth is pointing to. And so it's going to do this, right? It's going to make one gigantic circle. So let's wait for it to see if it's going to make a circle. I'm going to speed this up so it goes a little faster. You guys look. It's making a circle. It's drawing a circle. It's coming back to Polaris. Wow. Okay. The year now is 27,700. And Polaris is a North Star again. And of course, we're all going to come back. We'll be in the same class. Maybe next time Linda will be the teacher and I'll be a female sitting there watching the show. Right, like that. Who knows? You know, if Buddhists are correct, then there is reincarnation. Anyways, so that's what the precession of the Earth is all about. Precession is spelled Precession. Precession of the axis of the Earth. Sometimes, you know, they refer to it as the precession of the axis of the Earth. Sometimes they say precession of the equinoxes, because now the position of equinoxes is going to change too. Everything's going to change, right? If the whole North Celestial Pole, South Celestial Poles are going to change, well then, so does the equator of the Earth, so does the position of the equinox. Everything changes, right? So they're all changing. All right. They noticed a couple of thousand years ago that the North Celestial Pole is changing. The position of North Celestial Pole is changing. All right. Time is it? 1:19. All right. So now I'd like to share something entirely different with you guys. We're going to segue now into the eclipses. All right. The eclipses of the sun, the eclipses of the moon. And let's see what we have here. Let's segue into the eclipses of the sun first. Can you guys see this? Okay,
Yeah.
great. So now here's the sun sitting 93 miles away, 93,000 miles away. Here's the moon orbiting the Earth. It's much, much smaller than the Earth, by the way. It's like a couple of thousand miles, like going from the Canadian border to Texas. Much, much smaller than the Earth. You can put 50 moons inside the Earth, all right? Now, everything has a shadow. Everything in space has a shadow. Everything. So the moon has a shadow, the Earth has a shadow, and so on. When the Earth, from the Earth, you see the moon covering up the sun exactly, and it does. Right? It does because the moon's angular diameter from the Earth is about half a degree. So it's about half the size of your index finger and your arm's length. It's exactly the same size as the sun. However, because the moon gets a little farther from the Earth, a little closer to the Earth, the size of the shadow changes a little bit, all right? That's one thing. Also, look at the shadow. It's kind of tiny. Even in the best of circumstances, it's about 110 miles in diameter. Pretty small shadow on the Earth by the time it reaches the Earth. Something else I want you to notice. There's two shadows, actually. One is a full shadow. Look at this dark shadow, right? And I can't stop this from keep doing this, you know. It's like a GIF keeps doing it. No way to stop it. So look, there's a semi-shadow. This is where sunlight is. This is a semi-shadow, dark shadow, semi-shadow again. We call the dark shadow umbra. But I'm not going to ask you these questions because it's kind of like geometry and not geometry, biology. Biology, there's so many things to remember. Besides chromosomes, you know, you have to remember, I don't know, what else is there? Endometriosis, all kinds of stuff, right? So there's a whole bunch of names that are alien to all of you. So umbra is a dark shadow, just so that you know. This is called penumbra, like P-E-N umbra, U-M-B-R-A. Umbra, penumbra. So this is the dark shadow. It casts a dark shadow on the Earth, all right? If you're in the dark shadow of the Earth, you see a total eclipse of the sun. The sun will be completely covered. Exciting stuff. If you're in a semi-shadow, that means you can still see some parts of the sun. You're seeing a partial eclipse of the sun. Then there's a third possibility, and that's if the moon is too far away, you don't see the shadow completely, doesn't reach the earth. Instead, you see the ring of fire. You see the sun around the moon, which is the ring of fire. So I'm going to make all this for you guys in the program.
I'm sorry. When you see the ring of fire, that is because
The moon is too far away from the earth.
the moon is too far. And then the penumbra is the very dark one, or the.
Penumbra is the light shadow.
Thank you.
Yeah, it's kind of like, you know, the moon is covering the sun, but not all of it. So some parts of the earth will see a partial eclipse. I'm going to show you all this right now so you can see it. Okay, we're in the eclipse of the moon right now. I'm going to make an eclipse of the sun. All right, so the first case is a partial. All right, it's a partial. And the partial is happening right now. So this blue thing is the moon. This is the sun. And the moon is moving. The moon is orbiting the earth. So it covers the sun a little bit, but not completely. This is called a partial solar eclipse. So this is a partial solar eclipse. It doesn't cover it completely. All right, like that. Not very exciting. You don't even notice it unless you know there's going to be a partial eclipse. But when there is a total eclipse, it doesn't happen all over the world. So let me show you. First, I'm going to show you from space. All right, so this is from space. So this is a partial shadow. You can see the entire United States is going to be covered up. Look at that, covered up completely. So that means here, people here are seeing only a partial eclipse right now. Everybody here that's in this big, gigantic partial shadow can see a part of this sun. Little sun is out. Now there's a dark shadow here. Can you see this dark shadow? There's a very, very dark shadow here. It's easier to see when it gets closer and closer to the land. Here it is right there. Now, I was in Cabo, I think it was 1993 I was in Cabo. Was it 1990? I'm sorry, it was 1991. I was in Cabo, which is at the end of the Baja. So this is San Diego. This is Baja, California. At the end of Baja is Cabo, San Lucas. And Mexico City is about here. So now this is about 110-mile dark, dark shadow. This was the eclipse of the century because we saw the moon cover the sun for 7.5 minutes. That's maximum. Nobody has ever seen longer than 7.5 minutes of total eclipse of the sun. So now it comes in. Now it's on Cabo. So we saw it now. It was at 12 noon actually in Cabo. Now, other places, they're still seeing a partial. If you're seeing a partial, wear those glasses. You know, the glasses that you wear to see the sunglasses or eclipse glasses. But when it's a total eclipse, take your glasses off. You're missing the whole show. They made that mistake in England a few years ago. That was a disaster. All the school kids missed the total eclipse of the sun because they're wearing their glasses. Sheesh. Oh, what a bummer that is.
So you don't have to look through the pinhole box if it's a total eclipse.
Right. Take everything
There's
off.
a ring of fire. Maybe you have to.
Ring of fire you have to wear. Yeah. All the other cases besides the total eclipse, you have to wear. Yes. Now, this also went through Mexico City. And the reason I say that is because we had a live feed from Mexico City Zoo. Because the animals, when it got dark at 12 noon, they have a biological clock. They got nervous. You know, they thought it was dinner time. So the monkeys were apparently hungry for dinner even at 12 noon. You know, some of the animals, they're just always hungry. Like Linda probably knows her dogs. The 3 dogs are always hungry. You can feed them all day. They'll eat all day. They explode. They don't know when to stop. So we heard that. Now, this is from Cabo. After that, the shadow moved because the earth is rotating, right? So the shadow of the moon is racing across the earth really fast because the earth is moving. Eventually, after Mexico City, it went to Central America and South America. It went into Amazon and all that. All right, so that's what you see from space. Now, what do you see from Cabo? Let's make sure you guys can see that. I want to show something that not everybody can see. Can you all see this now? Excellent. So now it's going to be a total eclipse where the sun is going to be completely covered up. That's the dark shadow. Okay. Should I back it up? I think no. Forward, forward, forward. Completely covered up. The stars come out like it's nighttime. Unbelievably beautiful, you guys. First of all, it's like nighttime, and you have this reddish thing around the horizon. This beautiful, just like a sunset, but 360, all the way 360 degrees around you. Fantastic looking thing. And the light that you see around the sun, that's the outer atmosphere of the sun called corona. Corona doesn't mean a virus. Corona means a crown. So this is the crown of the sun, most beautiful thing you'll ever see in your life. Well, I always say after the birth of my kids, but honestly, the birth of my kids were disgusting. Yeah. See, I didn't even know there's going to be this big, the first time anyways, I didn't know this big giant bag of water is going to come out with the kids. There's this huge placenta, right? A gigantic bag of water that comes out with the kids. Oh my God. The first time I saw it, I go, wait a second, what do I have? A kid and a kid that it looks like a water bag? You know, what the heck is this? They had to explain it to me the first time. I'm sorry, I didn't read the book. Now, this corona is silverish light. You've never seen probably silverish light. The only time I remember anybody talking about a silverish light was somebody was explaining to me. Moses goes to Mount Sinai and he sees the light of God. And he said that was a silverish God, silverish light of God. So Moses, his hair turns white when he sees God. And you see this, your hair may turn white. I'm telling you, my hair turned white. My beard turned white when I saw this silverish light of God. I made a video. I'll put it up for you if you guys want to see it. It's only 9 minutes, but it's like I talk to people and I also show you a video of the eclipse as it's happening. And I was talking to people before and after, people that have never seen the total eclipse of the sun before. I ask them, what do you expect? What do you expect? And then afterwards say, well, what did you see? And there was this one guy who is an atheist. And he says, well, what did you see? He says, I saw the fingerprint of God. And I had to remind him that he's an atheist. What do you mean, the fingerprint of God? This is something you'll never forget. It's a once-in-a-lifetime chance. But you got to travel. I went all the way to Oregon, like, I don't know, 1,500 miles to see it. The one that is going to be really nice is in 2024. So it's 3 years from now in Texas. This is the best place to see it in Texas. It's very near Dallas. It might even go across Dallas because the shadow, remember, it's only 110 miles wide. That's the one to see, you guys. Before you die, try to see Eclipse. If you get rich, buy tickets to go on a cruise ship or something to see it because the cruise ships keep moving. So even if it's cloudy, it moves. All right. Now, the fourth. Oh, by the way, there's a couple of things that happened that I should mention to you. The shadows get really sharp. Like this. Okay, see, like the shadows from a crescent sun, they become much sharper. So you see a very, very sharp dark shadows. And the temperatures fall immediately, like 15 degrees. So you get chilled. Normally, I think that everybody's hair in the back of their neck stands up too, you know, so that's kind of scary. And first time I went was with football players from San Diego State. These guys were my students at San Diego State, and they started crying. I'm talking about linemen, like, you know, like 6'6", 300 pounds. They were crying. They're standing on a beach in Cabo crying, you guys, like a baby. That's because it's overwhelming. You know, it's like seeing God for the first time. Everybody kept saying it's just like seeing God. It's like, well, that's what it is. It's like being in Twilight Zone, not believing what you're seeing, like you're seeing something through a portal. That's what it's like. Okay. Well, I hope I gave you guys a little taste of this. Now for the eclipse of the moon.
So how long does it last?
Maximum 7.5 minutes. But I think the one in Texas is going to be about 4 minutes, and the one I saw in Oregon in 2017 was about 2 minutes and 20 seconds. But it's worth.
Professor?
Yeah.
So then do they get like longer like each time that they come up? Like,
No, it depends how close the moon is to the Earth. The closer the moon is to the Earth, the bigger the shadow is to the Earth, so the longer you stay in the shadow. But if you want to see it longer for like 2 hours, you get a ticket on a fast-flying airplane that can stay in the shadow for a couple of hours. Then you can see it with a window in an airplane for a couple of hours. It's an expensive thing, like a couple of $1,000 at least. But
would that be like Sophia?
No, Sophia is this big giant telescope. It's a 100-inch telescope. It's the same size as a Hubble Space Telescope. It's in a big 747, and Sophia doesn't fly that fast. It's a 747. You need to be much faster than that. You have to keep up with the rotation of the Earth. You go in the opposite direction of the rotation of the Earth. So I would say something that goes much, much faster. There's airplanes like that go much faster. I believe you have to go faster than 700 kilometers per hour, something like 650 miles per hour. I believe that's it. But don't quote me on that one. It could be wrong. All right. Now let's see the eclipse of the moon. Nowhere nearly as impressive, you guys. But it proves that the Earth is a sphere. This is a proof. I think it was Aristotle that first mentioned it. This is a proof that the Earth is a sphere. Not a flat Earth. It's a sphere, right? So now, same thing here. The Earth's shadow is going to fall onto the moon this time. And the Earth's shadow is much, much bigger. It's a huge shadow, right? So as the moon travels around the Earth, as it orbits the Earth, it goes through the shadow of the Earth now. Now, shadow of the Earth is not colorless like the moon's shadow. Shadow of the Earth is reddish. I'll just mention it to you why, but I'll explain it when we get to chapter 5, all right? You see, when you look at the sun at sunset, it kind of appears orangish, reddish. Why? Because as the sunlight goes through the atmosphere, the blue light has a tough time going through the atmosphere. That's why the sky is blue. The blue light of the sun, a lot of it is scattered by the atmosphere. The red light goes right through like a knife through butter, right? Hot knife through butter. And so the shadow of the Earth is kind of reddish. So that's what you expect to see now. Hopefully it's going to disappear. So it's also got two shadows. So the moon has to go through two shadows of the Earth, the light shadow and the dark shadow. Okay, so let's take a look now. Oh, geez, I should slow this down to 1 minute. Let me back it up a little bit. All right, so here's the light shadow. Now, what you notice is that the light shadow is not flat. It's round like this. It's like a part of a big giant circle. And then as the dark shadow comes in, look at the dark shadow. The dark shadow is also round. It's going to come in now. Look, see, it's also a part of a circle like that. And as it comes in, the moon gets bloody. When they say blood moon, it's nowhere near like this. This is blood moon. And the moon is going to stay like that for a while, like a couple of hours. So now it covers it up completely and stays red like that. Now, if the moon goes like north of or south of this shadow, and it only goes through the light shadow, then it doesn't get like this. It gets a little red, but not like this. We say that's a partial eclipse of the moon. This is a total eclipse of the moon. Happens quite often. And you can see it from the entire hemisphere of the Earth, not just from a special location. So a lot of people on Earth will be able to see it for a couple of hours. Right?
When do you get to see this sort of event?
Oh,
How is it
this year I think there's going to be a couple of eclipses. So I don't know which one is visible from San Diego, but you techie, who said this? Who asked that question? Who?
Cindy Costa.
Cindy, I'm putting you in charge of this. Come to class next time, please, and let me know when the next eclipse of the moon is going to happen in San Diego that we can see. All right.
Yes.
Thank you, Sydney.
You're welcome.
All right, Sydney. I keep saying Sydney. Cindy. Sheesh. All right. Now, last thing I'm going to go through is the phases of this moon. And I found something in KPBS. Somebody made a really nice app for the moon on KPBS. So I'm going to use that to show you guys. Let's see, it's here someplace. Ay, where is it? Where are you? Huh. Can't really find it, but I will find it. Give me a second here. Here it is. Can you guys see this, or should I have to? Do you see the moon and the sun and stuff, or no?
Yes, sir.
You do see. Oh, excellent. Excellent. All right, so let me bring the moon to where we call dark of the moon or the new moon. So this is the moon going around the earth, and it's very important for me to tell you how you're looking at this. You are all Superman flying above the North Pole of the earth. So here's the earth, and it's rotating like this. The moon is going around the earth like this. Those are both counterclockwise motions. Now, let me advance this by a day. Okay, there we go. It's pretty close. Advance it by an hour, another hour, another hour, another hour, another hour. Sheesh. All right, another hour. Oh my God. This is pretty close from the earth. When you look at the moon, you see no light at all. Now, sunlight and moonlight are the same thing. What we call moonlight is really sunlight. So this is sunlight. From the earth, we don't see any of it, right? Let me advance this guy here. So here's you looking at it. And we don't see the moon. It's right next to the sun. The sun overwhelms it. So we say this is the new moon here. That's the phase of the moon. You don't see anything. As it moves, a day is going to go by. And now you can see a crescent, thin crescent next to it. You see the thin crescent next to the sun here. So from here, you draw a line to the sun, you draw a line to the earth, and that's like a 15 degrees or 10 degrees or something. So that's how far away the moon is from the sun, almost next to each other, right? All right, so now let's move it another day. Look, it's getting farther from the sun. The angle between the sun and the moon is widening for us on Earth. And the more light we see on the moon, now, which light are we seeing? Well, look, this side of the moon that faces the Earth, that determines what we see. I think I might have to go get an apple or something from the fridge to show you guys a little better. Maybe next time I'll get an orange and an apple. So there it is. That's what we see now. Now let's go another day. This crescent is getting bigger and bigger now, and is widening. It's getting farther and farther away from the sun. Another day. All right, we see a bigger portion of the sunlight, moonlight on the moon. This is it right here. Right here, you see it? This, what's behind here, we don't see at all. We see this too. All right, let's do it again. Another day. Now look, it's getting farther and farther, and there's more and more light on the moon. We call all of these phases waxing. Like you wax your car, it's waxing. Except the moon is waxing. So this is a waxing phase. It's getting more and more light. And we call all these phases that you just saw waxing crescents, like a croissant. A croissant is just this, a crescent in French, croissant. Another day, now we're starting to see very close to a quarter moon. So let me go with just a few hours. I don't want to go too far. Okay, so now you're seeing a quarter of the moon. So if you think of moon as having 4 quarters, 2 quarters are back here, 2 quarters in the front, 1 quarter is dark, 1 quarter is light. That's why we call this a quarter moon. Now the angle here is 90 degrees. So from the sun to the earth to the moon is a 90-degree angle. So is this angle here, 90 degrees. So the sun is setting, the moon is due south. Not exactly though, huh? Yeah, we're not synchronized perfectly. All right, so now the moon is going to be even farther. Oh boy, I got us into the darkness, you guys. Let's see if I can move it. All right, that's better. Okay, now as time goes on, moonlight is getting a little more, sunlight is getting a little more, and these phases are more than a quarter, but not a full moon, right? What do we call these, you guys?
Gibbous.
Gibbous, very good. Gibbous. I'm going to draw this on the board for you next time with everything on there. So this is a gibbous moon. More than a quarter, less than a full. This is a waxing gibbous moon. And then we're going towards a full moon. Notice how far away the sun is from the moon now. Come on. It's going so slow. Come on. Got a class here. Oh, you very slow. So I can just move it. Sheesh. Sorry, guys. I just moved the moon. All right. So this one is the full moon. Sheesh. That's the full moon. Let me move it by 1 hour. Oh, sheesh. Bring it back just a little bit. Okay. Now, one of them is rising, one of them is setting. That's 180 degrees. The moon is rising in the east, the sun is setting in the west. So when the full moon rises, the sun sets. This is when the shadow of the earth falls onto the moon during a full moon. Only during a full moon we have a lunar eclipse. When do you think we have a solar eclipse, you guys? Oh, we're here, right?
A new
We have
moon?
a new moon, that's right. So the shadow of the moon has to fall on the earth. All right, so back to the full moon. All right, so full moon rises, the sun is already set. And then we keep going. Sheesh. I'm gonna move it now. Now we're gonna see the waning phases. Waning spelled W-A-I. Waning, N-I-N-G. Waning phases. So now we're waning phases. The moonlight is getting smaller and smaller now. Less and less light. Less and less light. Sheesh, moving so slow. Come on, one more. All right, now this is a waning gibbous. You see, waning gibbous. So waxing gibbous, waning gibbous. Waxing crescent, waning crescent. First quarter, last quarter, or third quarter. All right, so here we go again. We're approaching last quarter. Come on. Oh, I got to stop it and move it. So now we have a quarter moon again. And this is the last quarter or third quarter. So we see 1 quarter of the moon again, even though half the moon is lit, but we don't see the backside. All right. So now the last thing is crescents here. Okay, it's crescents. And these are called waning crescents. One thing I like to point out is this. The moon has horns. Horned moon, right? These are the horns of the moon, like a cow. It's got a horned edges here. So this is called the horns of the moon. It's got 2 horns. Now here's a trick. If you follow the horns of the moon, it's pointing away from the sun. So this is pointing away from the sun. If you follow it this way, it's pointing at the sun. So if you see a crescent moon, you should be able to see where the sun is, even if the sun is below the horizon. You follow what I'm saying? Okay. Yay. And then it's going to be new again. And that's it. Isn't that a cool app? It was a really cool app. Okay.